Okay, here with an attempt to teach slope fields. This packet's more the basics. We'll do a little bit more on 11.2 in the book, which I've included pictures of for you. So basically, a slope field is a thing representing all the functions that give this slope. So if you look at this one's pretty straightforward. In fact, we could find the equation that gives me this derivative. It's 1/2 x squared plus x plus c, so a whole bunch of parabolas, but we're not gonna worry about that. We're just gonna draw the slope field. So I'm gonna try to look for patterns so I don't have to go to every one of these points and draw. I'm just gonna draw a few of them here. So basically, we're gonna go to a point. So say we go to the point 0, 0, and we plug into here. Well, I only have a place to plug the x in. So if I plug a 0 in for x, I get that I have a slope of 1. So a slope of 1 here would point at that point. So I'm gonna draw a little hash dash here that points right up at that one. Since this only has x's, the pattern here is going to be it doesn't matter what the y is. So everywhere that x is 0, the slope is going to be 1. So I'm going to put a slope of 1 all of these places. Okay, if I move here, all of these places, x is equal to 1. Well, if I plug a 1 into here, I'm getting a slope of 2. So I start here, a slope of 2 would point at that guy there, up 2 over 1. So I'm going to draw along this one. So I'm just looking for patterns. If I went here everywhere where x equaled -1, if x equals -1, the slope is 0. So all of these would be horizontal. If I plug in a -2 for x, that's going to be -1. So these would look like this, and I think you get the idea. You could probably draw the rest of them. So if I go here, this one only has y's, which means if y is equal to 0, so all of these places, the slope will be 0, so you won't be able to see these very well because they're right on that line, but all of these would be flat slopes. Whereas across this line, so x doesn't matter, so I'm looking along horizontal lines. If I plug a 1 into here, the slope will be 2. So this would point up in this area here. All of these are slope 2. Now your slopes don't have to be perfect, but like slope 2s need to be steeper than, say, slope 1s. This line would be slope 4, so it's steeper still. This line down here, if I put in a -1, I'd have a slope of -2. So it'll look something like this. Okay, and I could keep drawing at all of those points. Usually on a test, there's only 12 or 15 points we have to draw out. Here is a little more complex one. I don't know what gave me this slope because it's got an x and a y, but I'm going to go to points and I'm going to plug in both an x and a y. So if I go to 0, 0, if I plug a 0, 0, I get 0 plus 0, which is a slope of 0. But that's not going to be consistent along vertical lines or horizontal lines. But if I give it a little thought, I think as long as x and y are opposite of each other, I'm going to get a slope of 0. So like at this place right here, 1, -1. If I plug a 1 in for x, -1 in for y, I get 0. And here at 2, -2, and -1, 1. So trying to find the patterns. Looks like this one's going to be consistent along these lines. So if I go here, 1, 0 gives me a slope of 1. So would 0, 1. So would -1, 2. So would 2, -1. So would 3, -2. If I went to this here, -1, 0, that would give me a slope of -1. And that would be the same at all of these places. And so on, you could keep drawing. You could see the key there. So you can keep drawing on all of these. I have the key. You can take a look if you have questions. I'd be glad to go through them with you. Here says we got to match up these equations with these slopes. Key here is these are slope fields, so these need to be sloped. So if I were to take the derivative of each of these, then it would be easier to match up and y equals what? -2 over x cubed. Y equals sine of x, so y prime equals cosine of x. Y prime equals -sine of x. Y equals 1 over x, so on and so forth. So what I mean here is if I was trying to match this equation up, I would probably think that it was here, but it's not. The slopes of y equals 1 are 0, so this number 7 here would be an answer of D. And y equals x is a whole bunch of lines that look like this. It would be slopes 1, so that would be h. And again, you can check the key. I'll let you go from there. Go to the last page. If it wants me to match up these, unlikely to see this. You know, we're only doing FRQs, but the way I would simplify this is this one only has x's. If it only has x's, it's going to have slopes along vertical lines that are consistent. That's going to be this guy right here, so this will be a V. This is the only one that only has Y's. So it's going to have consistent slopes along horizontal lines, making it its answer D. And then these two, I'll let you go ahead and try to find the pattern. You can look at the key and work backwards if you need to. Here, let's say here's a slope field, and there's a solution curve drawn through the point 0, 1. Please draw one through 0, 2. So if I go here, I'm just kind of following the flow of the river. This just pisses people off, but just act like you're a stick. You threw it in the river, and all you can do is follow the flow. So if I was at 0, -1, I headed right. We start turning down and down and down. If I'm at here and I turn left, we go down and down and down. Okay, if I'm drawing through here as well, so 0, 1 point here. And this, when it looks like this all lined up, that's an asymptote. So once you get there, you never get off of it. Going this direction, I go up here. And if you're feeling like this is all wonky, that's how you feel when classes feel when they're in person too. So just roll with it. Okay, and that's all for the slope field packet. I'll be back with 11.2. We go a little deeper into this stuff. Okay.